Assalamu alaikum students. In this video I will show you that how you will implement the linked list in C++, and I will show you that what is linked list and what is meant by the nodes and what kind of pointers you will use in implementing the linked list. So the linked list is one of the most important data structures. It is a kind of data structures we often face situations where the data is dynamic, as we have implemented the arrays in which only one data type uh, elements were used. So for the dynamic values you can use the linked list. In this lab I will only show you the linear linked list. So dynamic in nature, and the number of data can't be predicted, or the number of data keeps changing during program execution. Linked lists are very useful in this type of situations. The implementation of a linked list is in C++ is done using pointers. So you have to use the pointers to implement the linear linked list. A linked list is made up of many nodes which are connected in nature. All the nodes are connected. Every node is mainly divided into two parts. All the nodes have two parts. One part holds the data while the other part holds the pointer. So one part holds the data and the other part is connected to the different node, and that is pointer. Through pointer you will connect one node with the other. So the node consists of two parts, the data part and the pointer part. This is the pointer part which is pointing to the next node. As the node 1 is connected with the node 2 through this pointer, the node 2 is connected with node 3 with this pointer, and the node 3 is connected with this pointer. As there is no other node after node 4, so the pointer will be null of data 4. Here each node contains a data member, the upper part of the picture, and link to another node. The upper part is the used for the data, while the lower part is the link, and in simple we can say it a pointer pointing towards the other node. Notice that the last node doesn't point to any other node and just stores a null. So in C++ we achieve this functionality by using structures and pointers. So for implementing the linked list you will use the structures and pointers. Each structure represents a node. You will need a structure for representing a node having some data and also a pointer. As through diagram I have shown you that a node consists of a data and a pointer. So you will create a node by declaring it a structure. With the help of the structure you will create a node and the data and the pointer. This pointer holds the address of the next node. The pointer will be pointing to the next node, so for this the address of the next node will be assigned to the pointer and creates the link between two nodes, and in this way the link will be created between the two nodes. The first data member of the structure named node is an integer to hold an integer. As you have just simply write a node and declare it. This is a way of writing a structure, that you will write a struct, then name of the struct. The name of the struct will be node, and then the curly braces, and then for every node we will need a data and a pointer. So, and the curly braces then close with a semicolon. So we have to declare the data as int, and a next pointer. A next pointer is initialized with the name of the struct. As the struct node star next, the next node will be it is a pointer which will be pointing to the next node. So here is the int data and node starts next address of the next node. In this, the address of the next node will be saved, and the second data member is the pointer to a node. This means that the second data member holds the address of the next node, and in this way every node is connected. So the first member is the data, and the second member is the first member of the structure is data, and the second member of the structure is a pointer which will be point to the next node of the linked list. So here the int is the data, and next is the pointer which is pointing to the next node, as the next node address is saved in the previous pointer, and it will be same as in the next nodes in the preceding nodes, but the last node pointer will be null. It will be null as no other node is connected with it. So if we have access to the first node, then we can access any node of the linked list. For example, if A is the data is a node, then A will be pointing to, then A next is the node next to the A. The pointer storing the address of the next node is named next. One thing you should notice here is that we can easily access the next node, but there is no way of accessing the previous node, and this is the limitation of singly linked list, as you can access the next node but not the previous node. So that's why this is called a linear linked list. This is just the header, and then the structure, name, node, and then the int data. As you in the node you have two elements, the data, and this is the name of the struct. You have declare a pointer. So the start next is the pointer in the node, while the int data. Now we will create a class. After creating the node, now a linked list will be created, which will contain all the functions and data members required for a linked list. This class will use the structure node for the creation of the linked list. So with the help of the structured node, you will create the linked list. The second and the most important part of a linked list is to always keep the track of the first node, because access to the first node means access to the entire list. So let's call our first node as head. So we will call our first node as head. We have made two nodes, head and tail. We will store the first node in head and the last node in tail. The constructor of the linked list is making both head and tail null, because we have not yet added any element to our linked list, thus both are null. For example, if in the start if you are creating any linked list and you have no nodes, so our head and null will be assigned, head and tail will be assigned a null. So in this code it is just for the node, and then a class name linked list, and you have to create two nodes, the head and tail, and these are also the pointers, and you have to create it with the name of the struct. So node static head and static tail. So publicly I have created a constructor in which I have assigned a null values to the head and tail. So here our class is over, and then in the main I have just declare an object with the name of the class. So in this program we have just create a node and then assign the null to the head and tail. First we declare the head and tail, and then assign the null to the head and tail. Now in the next program I will show you that how you will create nodes. So here I have just created a node, a structure. The node consists of the data and the next pointer, and then the class linked list, in which I have declared two other pointers. One will be pointing the head and the other will be the tail. In the constructor we have to assign a null values to it, as we have no nodes. So the head is pointing to nothing, so that's why it's null, and as the tail will be always pointing to no node, so it will be already assigned a null. Then we will write a function that how you will add a node to a linked list. So here we are declaring a temporary pointer, and with the temporary point I will create a new node. First we will create a new node. Here we will create a new node. If I write here new, so a new node will be created just like this, and the node will consist of the data and the next pointer, but it will be assigned to the temp. Then I will assign the data n, as n value will be assigned to the data and the next pointer will be assigned null. And then we will check if head is equal to null. If head is null, mean no other node is assigned to the head, then head is equal to temp, mean that this temporary node will be head and this temporary node will be tail. Mean, for example, if we are creating a new node, so is a new node, so it will be the head of the linked list, and also it will be not pointing to any other node, so it will be also a tail. But else this part is for the first node, mean if you are creating a first node, but if first node is already created, mean if you want to create more than one nodes, so then the first, this is for the first node, this is for the first node. But if you are running the program again and we have already a first node as head, then the tail next, the temp will be assigned to the tail next, mean the tail pointer will be pointing towards the temp and the tail will be a tail next, mean the previous tail will be pointing towards the temp, because we are adding a second node to it. This is for the first node, but if you are running the program again and you want to insert the two nodes, so for the first node this program will run, and for the second node this program will run. And this here I just, the name of the class is the linked list, and just declare an object, and then with the name of the object you have to just call the functions twice. So in this way you will create two different nodes, 1 and 2. So here is the code explanation, that what is node temp is equal to node, we are allocating the space required for a node by the new operator. Now tmp points to a node or a space allocated for the node, mean if you are creating a node, so it just, we have to write a temporary name and then we will assign it the head and the tail to make a part of the linked list, and then assign the n value to the data. We are giving a value to the data of temp as passed to the function. Temp next is equal to null. We have given the value to data in the previous line and given a value of the pointer next null in this line, and thus making our node temp complete. As just we have assigned it a value n and a pointer null, that as there is no other node connecting with this, The next part after the creation of a node is to join the nodes and create the linked list. We will first check if the head is null or not. If the head is null, it means that there is no linked list yet and our current node TMP will be the head. The next part after the creation of a node is to join the nodes and create the linked list. We will first check if the head is null or not. If the head is null, it means that there is no linked list yet and our current node temp will be the head. If head is equal to null, then head is equal to temp, tail is equal to TMP. If head is null, our current node temp is the first node of the linked list, and this it will be head and tail both. Just I have told you that if we are assigning it our first node, so the head will be assigned to the temp while the tail will be assigned to null, as there is only one node, the last node, as it is the first and the last node, so the tail will be assigned the null. If head is not null, it means, but if you are then assigning a second node to the linked list, so the head will be not null. It means that we have a linked list and we just have to add the node at the end of the linked list. For adding a node, you have to check the linked list as either it is empty or not. If it is empty and there are no nodes, so the head will be assigned to the new created node. But if there are already nodes, so the pointer of that node we will be assigned to the our created node. The new node TMP will go after the tail, and then we are changing the tail because the new node is the new tail. So I have just changed the code like this, just like a cout node. So it will be give us the name of the nodes which we are creating. So here is the node consists of the data and the next, and then the class linked list, in which we have assigned the head and a tail null value as there are no elements in the linked list. Then through this function we will assign new nodes to it. So first we will check either the linked list is empty or not. If it is empty, so the temporary that the node we are creating will be assigned to the head and also to the tail. But if it is the we are creating the second node and any node is present already in the linked list, so the tail next as first node, as there is a node in the linked list, so the new temporary node will be assigned to the pointer which is tail, and the tail will be assigned the next pointer. So here I have just out the node, and in the main we have declared the object, and with the object we have called the function twice as we have created two nodes. So the output will be like this, that node 1 and node 2. So through this you can create a number of nodes, the mean what you want, how many nodes you want to create. So you have to just call the function according to it. So the lab task of this 9th number lab is you have to declare, initialize an array of size taken from user as input, display array values on screen. The task is same as that I have implemented in the lab, but you have to, at the end you have to do the summation of the array elements. Then the second task is receive input from user, that you have to receive input from you, store it in an integer variable, display what the user entered via the variable. So this is the part of the pointers. And then the third task is implement the code of inserting node in linked list in C++. You have to just implement the same code as I have given in the C++, but you have to I have only created two nodes. You can create more than two nodes. If you have any problems regarding this lab, you can contact me through this email, and hope that there will be no problems in this lab, as you have already learned these things in your theory. So thank you.